Okay, so now the black box is between the Mach 3 computer and the Gecko 540. It's all powered up, it's ready to go. So when the computer, the little embedded computer, wakes up for the first time, because it's been powered up, it's been plugged in, it defaults into the pass-through mode, where it's the external step and direction pulses that get relayed onto the 540. So it's exactly as if the box wasn't there. And so now I've got my Mach 3 running. And so from here, I can type in the commands or run a program. I'm going to just do it by using the MDI interface to set this thing in motion. The machine is set up now with 8,000 pulses, make one rotation of the main shaft. And so if I type the command then A for the A-axis 360 for 360 degrees, A360, and a feed rate of 3,000 degrees per minute, which is slow but reasonable. The thing will send into motion, and you can see it doing its turn at constant speed. And what I didn't point out is that there's a line on the top of the shaft there. You can just see it in the reflection, and there's this bolt here, the set screw, which shows that it's actually in the 0 position. And so I can go forwards and backwards. It works very, very well. Now with this computer, I'm running the Mach 3 kernel at 25 kilohertz. And as it turns out, the fastest I can get this shaft to go, the output shaft, to go with this kernel speed is about 3 rotations per second, or about to 180 rotations per minute. That's not very fast when you get down to trying to do lathe work, which is the whole point of this project. So you can't get this thing to go as fast as you want using Mach 3, at least not with these kernel speeds. The other problem is that you can't set up Mach 3 to freely run the A motor at any speed while it's independently running another program. And that's really the conflict that I'm trying to work around. So right now the machine is in this pass-through mode. It's Mach 3 that's controlling the system. But I can run now that terminal program, which is sitting here lurking in the background. And now any commands I type into this white space up at the top will get sent off to the black computer, and the black computer then is going to instruct or transmit the pulses the way I'm telling it to. So from now on, I don't think you have to see me typing. We'll just be looking at what the headstock is actually doing with those instructions. So right now we're in external mode. I'm going to type an I. That brings me into internal mode. And now the system is ignoring what Mach 3 does, and it's only listening to the black box. And so if I type a 1 now, you can see it's starting to spin into motion. And now it's doing a constant speed rotation, and it's simply ticking up the rotations. Mach 3 knows nothing about what we're doing at this point. Right now, the shaft is turning at about 150 rotations per minute. So this is very close to the fastest that Mach 3 could actually make it go. This is obtained by pressing 1 on the keyboard with the little program that sends commands over. But we can get this, that's only running 10% of full speed. So now if I type 2, it accelerates smoothly up to the next speed. This is now approximately 300 RPM. 30% of full speed, 40. So that's now running about 750 rotations per minute, which is probably about as fast as I intend to go with the lathe mode at any time. It can still go faster at 60%, and this machine will go up to about 70% or a little bit faster without any problems. If I try and go faster than that, I find that the motor stalls, so it simply can't keep up. And one of the problems with a stepper motor is that at high speed the torque becomes weaker and weaker, and so it's reasonable that it can't keep up at these higher speeds. The maximum speed that the software is set at right now is 1,500 RPM, which is about the maximum speed for this device with the Gecko 540. that's the maximum count rate is about 200 kilohertz coming in as a step pulse to it. So I backed it back down to 1 rotation per, 10% of the speed, so that's 15 RPM. And the shaft is turning clockwise as we go through, looking from this end. If I type 0 now, it's going to stop the shaft, but the interesting thing is going to be that because the computer knows exactly where the step pulses are, how many have been given, it's going to use that information to return the shaft to its original position. So I'm going to type 0 now. It stops, and now it does a rotation, and you can see that we're back to its original position with the line on the top and at the side. I can do that all day long. I could turn this up to very, very high speed. This is now 50% of the full speed. It could run like this for about 12 hours and still know exactly where the 0 degree mark is when you stop it at the end of the day. That's useful if you ever want to be going back and forth between Mach 3 and this rotation mode, so that you can always reposition the work exactly at the same angle each time when you make the flip to the other instrument. So it knows very well where it is. The other thing you can do, we're going at 50% speed right now in one direction. I can also reverse direction. And so if I hit a special key, it stops, goes to 0, and then accelerates back to full speed in the other direction. Actually, it's 50% speed in this direction. And so this works very, very well. Now, if I was trying to do this, what I would find is that over time, this motor becomes relatively warm to the touch. Warmer than I like it. And so we'll have to keep an eye on that and decide if it needs some cooling or something like that to run in the future. Okay? Now, if you're interested in much slower speed, I can stop it. It finds the 0. We're back to where we started. In addition to going in 10% steps of the full speed, which is about 150 RPM per step, the plus and minus keys can be used just to inch it up at 1% per step. So this is now turning at 1% of full speed. And if I go again, 2%, 3%, and so on. And then you can go . And it plays music to boot. So now I could easily go back to Mach 3 and we'd be back machining whatever we wanted to work on. So that's about it for now. Take care.